Beside monolithic architecture, in microservice architecture, services are separated. You can control all services individually. For advantages, we can count scalability and fault tolerance. Because all services are separated and independent from each other, you can scale up what service do you want. So it became a fault tolerance according to monolithic architecture, because if a service goes down, other services can continue their work and the whole application can continue. For disadvantages, hard to develop, deploy, and debug. Because there are many other services, it's harder than monolithic architecture, because you have to clone all services to your local computer and develop one by one and deploy one by one. We can continue with microservice architecture types. First one is synchronous architecture with composer. Second one is queue-based asynchronous architecture. First one is synchronous architecture with composer. In this type, microservices are behind composer. Composer can compose all the other microservices. It can call inner microservices via HTTP method like put, post, get requests. So inner microservices do not communicate with each other, so it provides a dependence of microservices. The second one is queue-based asynchronous architecture. In this type, every microservice has an input message queue. This queue can be implemented by Kafka or RabbitMQ. Or if you use cloud system, you can use AWS, SNS, Express solutions, for example. And every microservice may have an output queue. In this work, we demonstrate a simple e-commerce architecture with 3 simple services. First of all, the stock service. Stock service is responsible for the events that are related to stock operations. For example, increasing stock, decreasing stock, and adding a new item to the stock, for example. And second one is payment service. Payment service is responsible for payment-related events. It controls if a customer paid the payment successfully or not. And third one is order service. Order service is responsible for the order of a product purchase. Company can check if order is completed or anything else. And also we compare 3 different architectures. Firstly, is synchronous architecture with RESTful APIs. Secondly, event-driven architecture with sequential service triggering. Third one is event-driven architecture with parallel execution. First one is synchronous architecture with RESTful APIs. In this type, as I mentioned before, microservices are behind the composer. The inner microservices, stock API, payment API, and order API, does not communicate with each other. The life cycle of an order is composer gets the event and calls the stock API to decrease the stock of the product. And then stock API sends back to composer to result that if stock process is completed successfully or not. And then composer API calls the payment API, then make the payment, and payment API sends back the response to the composer. And then order API is called by composer and making the order. The 3 services completed successfully, then we can say that all the life cycle completed successfully. We triggered 40 parallel buy processes on Composer API. By the way, 1 second delay added to all inner microservices to simulate real-time execution. The total execution of time took about 3.04 seconds approximately. And we can calculate total execution of time by using this equation. In the equation, F is the execution time of a microservice and N is the number of microservices. So we can sum all the execution time to calculate all the system's execution time. The second one is event-driven architecture with sequential service triggering. In this type, the life cycle is stock service gets the event from stock event queue, processes the data, then sends to output to payment event. And then payment service gets data from payment event, processes the data, and then sends to order event. And then order event gets from order service gets from order event and sends the result to done event. You can check if the all life cycle completed successfully by checking done event. And we triggered 40 buy processes one by one to the stock event queue with using just one stock service, one payment, and one order service. It took almost all execution time took about 3.04 seconds approximately. The total execution time function is same as the previous one. And then we triggered 40 buy processes parallelly at the same time we triggered. And also we used 40 stock, 40 payment, and 40 order services. And then total execution of time is about 3.07 seconds approximately. This is bigger than the previous one because we triggered 40 parallel processes, not one by one. Total execution time function is the same as previous ones, by the way. The third one is the event-driven architecture, parallel execution. In this one, the life cycle is stock, payment, and order gets the event parallelly and then processes the event, then sends to their either done or error event. In this experiment, we triggered 40 parallel buy processes again to stock, payment, and order event at the same time. So the total execution of time is 1.01 approximately, 1.01 seconds approximately. In this type, the total execution of time can be calculated by this equation. In this equation, F is the execution time of a microservice and N is the number of microservices. We get the maximum maximum duration of a microservice. And when it comes to comparison, parallel execution of event-driven architecture is the fastest one. But microservices must be totally independent, and rollback scenarios may be difficult to handle, difficult to implement. For example, in our experiment, we use stock and payment service. Imagine that payment service needs an input from stock services output. So payment service is dependent to stock service. So we cannot implement this parallel execution because they are not totally independent. It is the important point. And also synchronous RESTful architecture is found to be only 0.03 seconds faster than a sequential event-driven architectures approximately. In conclusion, if there are complex business needs and there are many microservices to control, it would be better to use asynchronous event-driven architecture. And as I said in previous slide, choosing the event-driven architecture with parallel execution is the best solution, but the system must have independent microservices and you have to be careful about very strong and fault-tolerant rollback mechanism. And also, if there are basic business needs and there are not many microservices to control, it would be better to use synchronous architecture. In our experiment, we used just 3 inner microservices, so we see that synchronous architecture is just a little bit faster, 0.03 seconds faster than asynchronous architecture because we just 3 inner microservices. Maybe we may have 30, 40 inner microservices, so we should choose asynchronous event-driven architecture. And these are my references. And thank you everybody for listening to me. I can have your questions if you have.
Okay, any questions you want to ask to Mr. Gordesky? Can I ask a question?
Sure.
What was your implementation environment in terms of operating system?
I use Mac operating system and I use Go programming language. And also for simulating database interactions, I choose MongoDB. And also, I said before, I add 1 second delay for each microservice to simulate real-time code execution. If I didn't add this 1 second, it completes the execution maybe 50 milliseconds, so we cannot see the time differences. So I added 1 second delay into all microservices.
In the Mac operating system, do you use like threads or something for parallel processing? Or? Is it like Linux? That's what I wonder.
In Go programming languages, you can run parallel executions using Go routines channels also. In my previous slides, I can show you. I triggered 40 parallel execution. In this experiment, I cloned 40 stop, 40 payment, and 40 order services. They run parallelly, and then we triggered 40 buy process at the same time. So I think my computer's core is 16 core, but I tried 40 processes, so it runs parallelly as it can. But yeah.
Okay, thank you.
Thank you very much.
Okay, our second participant is a novel approach to detect fake news using extreme gradient boosting. Okay, from Dr. Reddy, Dr. Aswati, Dr. Mandal, and Dr. Kasya. This will be online, I believe.
Am I audible? Hello.
Hello, can you turn on your slides, please? Hello, can you hear us?
Yes, I can. Am I audible?
Can you turn on your slides, please? Can you share them?
Yeah.
Okay, we see a lot of windows within each other.
It is visible, right? Hello. Hello. I can't hear you. Am I audible? Shall I start? Hello? Hello? Am I audible, sir? Okay. A very good morning to one and all present here. I'm Ashweta Reddy. I'm a master's student at Vellore Institute of Technology, Andhra Pradesh, India. First of all, I would like to thank you for giving me an opportunity to showcase my work here in this platform, and of course, my co authors for their consistent help and guidance. I would be addressing on the paper a novel approach to detect fake news using extreme gradient boosting. So every day we come across some rumors and fake news. One such being yesterday, my father said this that he was scrolling WhatsApp and he came across the news that dinosaurs cannot be completely extinct and they can be back in life with just the help of an egg kept in a museum. So to make him clear about it, let us proceed with the proposed work and the purpose of the work present here. Okay, the main objective and the purpose of my work is looking for the authenticity of the news in social media to combat the consequences caused due to the spread of such news. By proposing such a method for early prediction of the fake news, it would also increase the accuracy of the result found. Looking forward, we shall take a small introduction and get into the method so that I can clearly and confidently ask my father to cut off his unreliable sources and get to know that the longest dinosaur we can have here is only a lizard. Okay, so getting into the introduction, the term fake news refers to the way of thinking about how news is produced. Actually, many such stories claim to state facts and they actually are not from such a reliable sources but is spread humongously resulting into the misinformation. Such misinformations have been greatly increased due to the use of internet, especially social media platforms like WhatsApp, Facebook, YouTube, Instagram, and so on. Here in this particular work, we are taking liar data set, which is taken from Kaggle. The link has been given in the slide below. Many developing technologies like big data, deep learning, natural language processing has been conducted to detect the authenticity, the originality of the news. This proposed method is a combination of semantic and syntactic analysis of statements using ensemble method, ensembling of which methods will be discussed further. First, let us look into the data set, which is being classified into six different classes, namely true, barely true, pants fire, half true, etc. This is the graphical representation of the classes, different classes of the data set. Moving forward, the proposed method has a framework which says the news article is being collected and preserved for future use. After that, we take only the required items, the data that is aligned to our research area, and rest are discarded. This comes under data scrubbing. There comes linguistic feature extraction, the extraction of features like hybrid features, semantic features, syntactic features, morphable features, that is which can be further modified in future. And the extracted data set is being split into training data set and testing data set in the ratio 7 is to 3. That is 70% of our data set would be trained. Now how do we train it? We train the model under ensemble model training. Ensemble implies ensembling of two major methods, one being logistic regression, one being extreme gradient boosting. Logistic regression makes its decision using the probability value zero point 0.5, greater than zero point 0.5, it gives the binary output 1, and less than zero point 0.5, it gives the binary output to be 0. It also considers extreme gradient boosting, which is a tree-based algorithm used for both classification and regression. Considering all the hyperparameters as in the parameters which takes the value externally, is tuned the hyperparameters are tuned in the ensemble training, and the trained model is ready. Now the testing happens using the testing data set, which is quite simple, and the classification is there into either true or false. Once it gives a good accuracy with the testing data, we take an unseen example which is not involved in the testing data set. Now, since it was not involved, we have to check whether it gives a correct, that is, the news is correctly classified to be true or fake or not. The method is being explained here completely. Moving forward, we have done some experiments and got some results. Let us look into that. There are two word clouds explicitly showing the words included in the true statement and the words included in the false statements. The word clouds, what does they do is quickly break down text from an article or survey and allow the viewer to see which words are more or less frequently used. This would summarize the statements in the liar dataset in only a very few words, and word cloud in gist would give us a preliminary stage of detection, prediction, that whether the word lies in the true word collection or the false word collection. Moving forward, we see an experiment, as already told, that unseen example, unseen piece of news article. That news article says it's been 14 years since a president or a member of their family has not gone and attended at least an event at the Olympics. This was the piece of news for which we'll check. Word cloud is being generated. POS tagging of input, the implementation is done, followed by data pre-processing and stop word removal, which includes lemmatization, etc. And then the data is being transferred to logistic regression, the model for classification, and hence it is found to be classified as true news. Here we see a verify, basically an example of for the validity of an unseen news with our proposed method. Coming up, what do we see? How to make what makes a model to be the best one? Okay, so a model to be proved as the best one, let us take an example of dart where we put in arrows to get 100% accuracy. How do we get that accurate and precise result? Let's check. If it is high bias, high variance, we get more spaced arrows. The more is the distance, the high is the variance, the less precise it is. Similarly, the low is the variance, the more precise it is. So in conclusion, the conclusion I can draw from here is low variance and low bias can make it to be the best model. That is high precision and high accuracy. So can we just check for the accuracy and precision of our model? Here it is. The accuracy with our results, with the values input here, is coming out to be 0.98, that is 98%, and other measures of confusion matrix like sensitivity, specificity, including precision. Let's check for the precision value. It's coming out to be 0.9897, that is approximately 99%, which is a quite good number. So, and also we found that the accuracy, and apart from accuracy and precision, the computation time it takes is comparatively less than the pre-existing models. So if we are talking about the pre-existing model, let us just compare it with the models. The comparison of the proposed method with other pre-existing models includes a box plot representation, which gives the gist of the methods like BERT-based language model, MNB in blockchain, natural language processing, naive-based, support vector machine, etc. These methods give an use for basically detecting the fake news, and they are giving an accuracy of 70%, 95.2, 75, 71, 74% respectively, which is relatively very less than what we have got for our method, that is ensemble methods using logistic regression and extreme gradient boosting, and the accuracy is coming out to be 98%. That means 98% we are sure that whatever we are predicting about the news is correct. Either it is false or true, we are 98% confident about it. Proceeding, we conclude, and the focal point of this whole work was to accurately predict the early results for the news, whether it is fake or not, so that it basically creates an awareness for the propagators, and the originality of the news is maintained to a high scale. And also, as already mentioned, the computation time is decreased as compared to the other pre-existing works. In future, we are looking forward that our proposed method is deployed in social media, and the method can be used as a feature in further mobile applications, PCs, laptop, to filter out the fake news before reaching out to the masses, so that the masses don't have to completely depend on such platforms for the authentic news they come across daily. And this would also help the sources to maintain the originality. And as I started, I would be confidently able to make my father understand that yes, dinosaurs are extinct completely. They are not going to come back with just the help of an egg. So these were the references taken in the paper. I used 37 references, which are stated below. Here are they. With this, I come to the end of my presentation. Thank you. Just a clarification, I'm not getting any voice from that side. Hello.
Hello?
Hello.
Hello?
Yes, sir.
Hi. Hello? Tamam. Okay, bir sonraki sorun. Okay, we want to move on to next presentation, which is by Dr. Youssef, Dr. Serkan Marov, Dr. Serkan Chapma. The topic is called Medical Fatality Analysis by Gender Using Predictive Analytics. Okay.
Good morning. This is Dr. Serkan Marov from University of Tennessee at Chattanooga. This paper is a product of my data science class that I teach to grad level students at UTC. So what happens is that students get to choose a topic, then they collect the original data and do some predictive analytics. So we are going to go ahead and start with some literature review. It's very common sense that traffic accidents are killing people on the road, so I'm not going to go over the details that we do not need. But how it started is that Mana Youssef, he's the author of this paper actually, he wanted to investigate the crash data and he wanted to collect some data from the Tennessee government. And he did some literature research and he made some analysis based on the fact that there were less accidents after COVID-19 and there were less fatalities on the road. So he found that in 2020, almost 40,000 people died as a result of traffic accidents, and that is marking the highest number of fatalities since 2007. This finding was an important one, and it's an interesting one because we see less cars on the roads after COVID-19, and along with the gas prices that we're getting right now, but still the numbers are just keep climbing up. And in 2020, fatality per 100 million vehicle miles traveled, we call this MVMT, was at an increase of 1.34 fatalities per 100. Another finding that he got, let me go back to the previous slide. So female involved in motor vehicle fatal accidents show an increase. So this kind of constitutes the main purpose of this paper. So we wanted to do some data analytics on comparing what happens to female versus males on the road in terms of the number of fatalities. So again, male drivers are more often involved in severe crashes than female drivers, but those females are more likely to be killed or injured in crashes of vehicles severely than males. This is another interesting result that he was able to obtain. Even though male drivers are more often involved in severe crashes than female drivers, females are more likely to be killed. There are different predictors, there are different factors that may contribute to this finding, this important result of this paper. And there could be tons of reasons. It could be the driving behavior or the driver characteristics, environmental reasons, you name it. And this is what we wanted to investigate. What is really affecting the number of accidents on the roads? And another finding that we got, male crash deaths were more than twice that of female crash deaths. So from 1975 to 2019, male crash death declined by 22%, and versus female crash deaths declined by 12%. So one of the motivating reasons behind this could be the labor force participation. So this figure kind of summarizes the labor force participation rate, women versus men, starting in 1975. It just keeps climbing up. So labor force could be the contributing factor in this case. Of course, we're just talking hypothetically here. We do not know the exact reasons. And again, there could be tons of different reasons that could be affecting this finding. Our focus here is the state of Tennessee. So we are from the University of Tennessee at Chattanooga, and we just wanted to do our analysis in our state and help our local government to make some implications out of this result that we're hoping to get. So let me tell you a little bit about the state of Tennessee. We find that the state has almost 400,000 more people than the US average. So it's somewhere in the middle in terms of the population, but we travel more. We do have some local transportation sources, but they're very limited. So we travel more than the US average. And the state suffered almost 388 more fatal crashes, almost 427 more deaths, making the state have a higher death per 100,000 population rate by about 4.79 than that of the US average of 11.81. So those are some facts about the state of Tennessee. And this table compares 4 different states. It kind of shows where Tennessee stands in terms of the population, miles driven, fatal crashes, and deaths. So Tennessee is somewhere in the vicinity of the Maryland, Indiana, and Massachusetts area. So the populations are very similar, the miles driven, pretty much similar with Indiana, but Maryland and Massachusetts are a little bit less than those 2 states that I mentioned. But look at the fatal crashes. We do see more accidents, and as a result, we do see more fatalities on the road. So what is really causing that? Is it the highways, or do we get to have some potholes on the streets? So we want to see the driving factor. We want to see the factors that are affecting this. So the next slide kind of summarizes the objectives of this paper. Actually, there's a single objective. We want to determine the contributing factors for female driver involvement in crashes that result in a fatality in Tennessee. So methodology, We collected this data from fatality analysis reporting system. So what they do is that they collect data about the traffic accidents, and that includes the vehicle, make and model of the car, the driver-related attributes, whether the age is less than 18 or more than 18, whether the driver was using alcohol. There are tons of factors that they list, and it's a huge database. Again, they've been collecting this since, I believe, 1975, so it's a huge database. So we took a look at the data set. There were approximately 201 columns and more than 54,000 rows of various data points collected by the agency to report on crash data. Well, of course, we had to filter the data because it was a huge data set to deal with. And after filtering the data and only selecting the state of Tennessee, there were around 2,000 rows of data points left. And we only considered the accidents where only 2 vehicles were involved, because we understand that there are certain dynamics that affect the accidents on the road. Think about it, when 2 cars are crashing, I think it's a whole different story than when 3 vehicles are involved in an accident. So we only consider accidents where only 2 vehicles involved. So this is the methodology. I know that the table is not readable from there, but it kind of contains the variable names, the variables that we use, and the data input and the description. So we do this descriptive analytics to get an understanding of what's really happening in this state. Again, there are variables that are important to us, like the weather condition, the vehicle make, model, whether the driver has a ticket before, well, whether the driver had a traffic incidents in the past, whether the driver had a traffic speeding incident, the number of crashes that he or she had in the past, the age, gender, whether he was or she was using a seat belt, or what else? I'm trying to check all the variables here that are important. Or the first harmful event. I think that is number 4 on the table. So how did the accident happen first? So what really caused that accident? Was that the pothole on the road, or that was an object on the road that causes accidents? So that kind of gives that information. So we used 4 different predictive models. That includes decision tree, forest model, and naive bias, as well as the logistic regression. We could have used more, but we determined that those 4 are the most suitable ones for our model. Each model has its own advantages and disadvantages. Decision tree may give you less accurate results, but it's easier to understand. Random forest, more accurate results, but it's a little bit complex to understand and kind of interpret the results that we see on the table. And then we use the naive bias and logistic regression model. So we kind of eliminated support vector machine actually for no reason. But we ended up having only 4 models here. We could have extended this to other models, but for now, I guess those 4 models will suffice for the short term. So we ran the model. We actually used the cross-validation tool, tenfold cross-validation tool. We took the 80% of the data and used the tenfold cross-validation tool. Then we tested our models on the remaining 20%. And based on the results that we got, Forest model was the winner here. It has the best accuracy, best F1 score, best specificity and sensitivity numbers. So as an example, an accuracy score of 0.706, which is 70%, it kind of indicates that the model can classify 70% of female driver involvement in vehicle crashes resulting in fatality. And Forest model yields sensitivity of 83%, which kind of indicates that the model is highly capable and highly accurate because it's capable of identifying female drivers' involvement in accidents. 83% is a good number. And then we have the F1 score. So F1 is a combination of precision and recall numbers, and 0.763 ensures that the model that we build is a robust model. So after running those tests, we ran the variable importance plot, and that kind of summarizes what variables are the contributing factors to accidents. So if you look at the variable importance plot, the first variable that we have is the driver height, the driver age, the driver, looking at it right now, whether the driver had a ticket before or not. So those are all the contributing factors. So mostly driver-related attributes are playing a more important role in traffic accidents comparing to the environmental reasons. And we also ran a different statistics that we're not showing here for another state, and that state was Georgia, and the results were different. In the state of Georgia, environmental factors were more important than the driver-related attributes. So each state has its own characteristics, I believe. But again, this kind of gives you the top 30 or top 20 factors that are important when identifying, when classifying the fatalities on the road. So we could kind of talk about the conclusion here, but I guess the most challenging part here was the data cleaning part. There were lots of data that were not correct. Some fields were missing, the age factor, the gender, and we had to clean that data first. And we ran an auto clean function on Alteryx platform to standardize the data and make the data ready for this type of analysis. And for the future work, we can always add the support vector machine, which is a more powerful predictive model than the ones that I mentioned, honestly. And we can try to get a more accurate result based on the support vector machine models. And again, support vector model has different kernels, and we can try different kernels, RDF kernel and other kernels, and try to stretch our results up to higher numbers. Those are some of the references that we use, and I believe that is it. Any questions?
Okay, thank you, Dr. Varro. Do we have any questions?
Yes.
Thank you for the presentation. You said that two cars involved generally.
Thank you. You talk about two cars involved in an accident. So, for example, one driver got alcohol and other driver is a good driver, for example. In your data set, the other driver who didn't get alcohol or drive safe, is he or she involved in your data set? So
No.
maybe it brings the data set.
It does. So it was, we thought about it. We even thought about separating data into different smaller data sets to kind of observe that situation, but it was a difficult task. So our data set do not address that type of information, that type of concern. It's one of the, in fact, we put it on the paper, it's one of the drawbacks of this study. We need a further investigation to find out whether the driver, the other driver, the male driver who used an alcohol had a more contributing factor than the female driver who did not use the alcohol. But that needs further deep investigation. And again, this was a product of my data science class, and we only had 3.5 months to complete this. But same student is my master's student, and he will be expanding this study further and will be completing his capstone project on this. And it's one of the limitations that we have right now, but we are trying to overcome that problem by doing a deeper analysis of that.
Thank you very much.
No problem.
Okay, we want to move on to our next presentation, which is a video presentation, I think. That will be from Dr. Raza, Dr. Hussein, and Professor Asaf Barol. The topic is called Performance Analysis of Deep Approaches on Airbnb Sentiment Reviews.
Hello everyone, my name is Linguistic. And today I am here to present my paper entitled The Performance Analysis of Deep Approaches on Airbnb Sentiment Reviews. You can view my email so that you can reach to me for my contact information if you have any questions regarding the presentation. The table of contents of my presentation include a set of topics like Introduction to Airbnb, the paper objectives, deep learning methods used for the analysis, the results of the DL approaches, and last but not the least include the conclusion. First of all, the introduction to Airbnb. This word Airbnb is much familiar to us that we use the services in our daily lives. The Airbnb, also known as the Air Bed and Breakfast, is an internet marketplace that lists and arranges local homes and extra living spaces for the short term or maybe for the long term rental purposes. It was founded by a group of three persons, Joe Jabia, Ryan Chesky, and Nathan Lekarsik, and it was founded in 2008. For the initiative of Airbnb, Jabia and Chesky first of all used their own home as an Airbnb host place, as a supplement to their income and to pay their rent. After that till now, it has provided about 7 million houses and accommodations in over 81,000 locations across 191 countries throughout the world. Some of the objectives of my research paper include, like we all are much familiar with the Airbnb services, and millions of people are staying connected as the hosts and guests in the Airbnb platform. So after availing the rental purposes and rental services of the Airbnb, the guests tend to share their experiences on the online Airbnb portal in the form of comments and reviews. This feedback assists other thousands of people in deciding or consulting the same services or location. The comments of people may include positive, negative, as well as neutral reviews, which will affect the popularity and reputation of the hosts and their offered home services. Therefore, the analysis of the online customer reviews is considered a crucial task that will affect the decision-making process of new customers. Sentiment analysis. It is an analytic technique which finds and extracts the subjective data from the source content. Through the sentiment analysis, an organization will identify social perception of their products and services by analyzing the online discussions and conversations. The purpose of sentiment analysis is to derive the data from customer comments that can improve the predictions models' performances and increases the accuracy of the model's results. Nowadays, sophisticated AI algorithms, such as the machine learning algorithms and the DL approaches, are creatively being used, which are used to conduct in-depth analysis of the different data sets. Deep learning. Deep learning is a field of AI that mimics the human brain activity and allows computer to function and think like the one. Within a TL architecture, we have different types of layers, including the input layer, a set of hidden layers, and the output layer. One of the type of DL algorithm includes the RNN, the recurrent neural network. It follows the backpropagation algorithm in a network and keep an internal memory of the current input, as well as the output from the last memory. They are both fed as an input to the current cell, which will make correct predictions. Long short-term memory, also known as LSTM, is a type of RNN that overcomes the problems of RNN by ensuring long-term dependencies and makes it the ideal situation for sentiment categorization. It is also used to overcome the vanishing gradient problem. GRU is another RNN type that functions similar to LSTM and addresses the short-term memory using two more gates, such as the update gate and the reset gates. Within the RNN architecture, we can view different types of layers like input layer, the hidden layer, the output layer. The data from one layer is passed to the second layer, and in this way, it forms a sequential pattern. So RNN can be said to be a feed-forward network in which data is passed and moved in a sequential manner. However, due to some of the difficulties in RNN, such as the absence of the backpropagation in RNN, will force the scientists to discover a new method known as the LSTM method. Within the LSTM method, it uses the backpropagation of the process and it maintains a long memory of the process so that correct predictions are being made. The three types of gates used in the LSTM include the forget gate, the input gate, and the output gate. Limited amount of information is being forgetted by the process, by the cell, which is done by the forget gate. The input gate gets the input in order to process for the analysis. However, the output is taken using the output gate. Gated recurrent unit used to another new gates known as the update gate and the reset gate, instead of the input gate and the forget gate used in the LSTM. Within our strategy, first of all, we collected the Airbnb review data set from the online Airbnb platform. The data is being pre-processed by adding different new features, removal of different odd features. The third step includes the aspect identification, on the basis of which sentiment classification is then carried out. After that, the fourth step includes the sentiment classification using different deep learning approaches, like the RNN, LSTM, and GRU. The results are identified by using different classification matrices, such as the precision, accuracy, reference score, and support. At the last, it identifies the best DL approach and gives suggestions on locations features. Within our data set, it consisted of about 13,051 customer reviews, in which it included different columns, such as the number of bathrooms, the number of bedrooms, the time period during which the guest was being hosted at the place, and so on. We also extracted the word cloud of different reviews in which we can identify different prominent words that would help us in sentiment analysis. By comparing different results of the classification methods of the three approaches, we can identify that the GRU method performed the best as compared to RNN and LSTM. The first 5 epochs of the process is being is being differentiated using three approaches, in which we can observe that the GRU approach is far most fastest as compared to the other two approaches. And the line graph also depicts the length and the time period during which the analysis is carried out by the three processes. For the conclusion of the presentation, like the study undergoes the sentiment classification of Airbnb reviews using three different DL approaches like RNN, NST, and GRU, and their classification matrices values are being compared. The experiment shows that the GRU outperforms RNN and NST with respect to the accuracy rates and other performance results. The results will help new coming travelers to come and visit particular places by trusting on the previous tourist comments. Thank you for your consideration. If you have any questions, you can contact me through my email address. Thank you.
Okay. We can't have really online questions because this is a video recording, but as Dr. said, you can contact him through conference administration. Our last presentation in this session today is by Dr. Bilgin and Dr. Tepe. Classification of tissue types in histology images using graphic neural network. This will be an online presentation. Hello?
Hello. Now I think it's not seeing my slides and it's uploading now.
Oh, we can see your slides. We can see you with your computer desktop, I believe. Can you share your slides?
Okay, I shared.
All right. Efendim? Okay, we can see the slides.
Okay.
Now, just one moment. All right. We can see them. Okay.
Okay, thank you. I am Esra Tepe. I am the master student in Yıldız Technical University, and I'm working on Doçent Dr. Gökhan Bilgin. And this is my thesis. This work done with my thesis subject, and classification of tissue types in histopathologic imaging using graph convolutional neural network. My outline will be like that. First, I will talk about a little graph convolutional network and graphs as a motivation, and then I will explain graph construction and experiment and result. Firstly, I want to talk about a little bit graph. Graph is the good graph is a data structure that represents the some problem, and it's a good representative structure. Graph is everywhere. We can represent many problems as a graph. For example, social graph, molecular graph, on transportation graph, and in here there are many problems also we can represent in the graph, and it's a good way to represent. For example, intuitive graph is a huge graph, and nodes can be people, and edge can be following station, and it shows us the structures of the all this. And another example is molecular graph. Molecular graph is the for example, this is the molecule, and we can show the atoms as a node, and then we can show the boundary as an edge, and then we can represent this molecule as a graph. And in the molecular graph, there can be many problems. There can solve many problems. For example, mutation type or mutation type. The other example can be transportation graph. It shows all the way which way is easy, which way is long. It shows us. And And the problem is in here. The problem is in here. Graph is irregular data structure. Machine learning and deep learning model generally work on regular data structure, like image length time series, and it gives very good accuracy and give very nice solution on it. But if you wanna apply machine learning graph like data structure, data structure like graph is not will be good, because if you wanna try, if you wanna feed our deep learning model graph like data, firstly we need to flatten out this graph. We vectorize this graph, and then we will give as an input in deep learning model, and it will cause some information loss. And in the pretty way in the graph is the connection and all this information. And when we flatten out the graph data, we lose many biases, and good way to represent things is we lost it. But we know that deep learning and ML, machine learning approach gives good solution. We want to apply in the graph data, and the motivation comes from here. For example, neural network, convolutional neural networks on images give very nice solution and give very good successful. And in here, in convolutional neural network, we don't take 2D images like a time series. We don't flatten the structure. And here, there is a convolution logic behind it, and it doesn't lose the bias on the images type. And the graph neural network want to apply this logic on the graph also. How we can apply convolution logic on the graph data? This is our problem in here. And convolution operation seems like in here. Convolution operation, sorry. Seems like in here, and we have a filter, and we take this filter take all neighbor pixel and aggregate them and show one result for them, and it's a high level representation to express image data like 2D images. And we want to do on graph data. How we can do this? And the problem is in here, in image data, this is the fixed 2 by 2, and for example, it's known every pixel has 9 neighbors. But in the graph data, it's not like that. A node can have 1 neighbor, or a node can have 5 neighbors or million neighbors. It can changeable, and we want to apply this logic on the graph data. How we can apply this? This is the this logic calls message passing on the graph. We want to take message from neighbors nodes of one node, and we aggregate all this information and update the target node. This logics comes from convolution operation. And for example, in here, node A, we wanna update node A, and we take message, it's called message. We take message from B, the neighbor B, neighbor C, and neighbor D. We aggregate this message, and we collect with oldest information to node A. This is the important one, and we update node A situation a new way. And after one iteration, these node E informed by the one layer neighbor. After 2 iterations, this node A will be informed by 2-level neighborhood, because before, in the first iteration, node C takes information from node F, and after second iteration, A will be learned the second neighbor of second layer neighborhood. And this iteration will go number of node time, and after all iteration, one node in the graph will inform every other node on the graph, and it will share some information about another all node. The logic comes from here, and then it's the good way, and it's the new way. It's the new approach also on graph. And this call graph message passing on the graph neural network, and according to aggregation function, it can be some operation, or other operation. There are many types of graph neural networks, and according to this situation. But in here, in my problem, I will explain this. I use graph convolutional network, and before that, I need to show that things. In the graph data, there can be different types of problem. Node classification can be one problem. In node classification, in our graph, in this example, I show a little node, but normally, for example, the network like social network, for example, Facebook graph, there are huge graph. There are millions nodes, millions edges on there. And in graph like that, node classification is very meaningful. And for example, in here, this node is known, this two node is known, but in this node, it doesn't know. In this station, node classification, with node classification, we know which class belongs to this node. The other popular problem on graph data like graph, the graph classification. In this problem, we have many graph, and we wanna some of them, many of them is labeled, and unlabeled graph. There are many unlabeled graph, and we wanna label this graph. Which type of graph we can? These two are the popular problem on the graph and graph neural network, graph convolutional neural network. And in my problem, also this process applied many problem, molecular problem, or social network problem, and also image problem. I didn't show in here, but there are many articles about that. It's also used in image dataset. And in here, I'm working on histopathological images, and I want to apply this logic on the histopathological images. And this is my dataset I use, PanLook datasets. This is the colon and rectum cancer dataset. And it has 7 different tissue classes: benign, complex stroma, debris, inflammatory, muscle stroma, and tumor. In here, my dataset consists consists on patches. Patches is 520 patches, and I want to class these patches. And to do this, I create patch graph. What is the meaning of patch graph? Patch graph is I'm taking this patch and I'm creating a graph, and after this, this is one graph. This is another graph, and I have many graph in here. And my problem becomes a graph classification problem in graph convolutional networks plan. And how I this is the very important part, because the hardest one is in here, the graph construction part. How I construct graph from one images. In here, I use first I segmented the graph, and then I create the graph. When I segment it, I use superpixel. And what is the superpixel? Sorry. What is the superpixel? Superpixel is the collection of pixels that share similar feature. Sorry, in here. And for example, in these images, let's say 1 million pixel. But when I divide to the superpixel, I have let's say 100 superpixel, and every superpixel share the same similarity feature, the neighborhood pixel. And it's very useful in the segmentation problem and also computational efficiency using pixel, more than using pixel. How is computational efficiently? For example, if I'm using this as a pixel, I deal with 1,000 pixel, but when I create super pixel, this time I need to deal with 100 super pixel. That's the that's the computational efficiently and perceptually meaningful also. Oh, sorry. What's the meaning of that? Instead of only examining a single pixel in the pixel grid, which carries very little perceptual meaning, pixel that belongs to superpixel group shares same sort of commonality and suggest similar color and texture distribution. And in that mean a lot using superpixel more than just pixel. Graph. The other special on it is graph over superpixel. When I am before superpixel, if I wanna construct graph, I need to use every pixel as a node. That means I have 1,000 nodes. But if I create superpixel, I need to create 100 nodes graph, and it's the easy to create graphs over superpixel. And superpixel also shares same similar feature, and it's the easy way, that's the nice thing. And I create superpixel using simple linear iterative clustering algorithm. There are many ways to create superpixel, but Slick algorithm is the easiest one, according to some article I put on the there, and this is show that this is use the adoption. It's Slick algorithm use the k-means superpixel generation, and it's use 5D CLab color space instead of RGB color space. And in here, there's some notation definition. I put some notation definition. And shows the number of pixel and shows the number of superpixel. Before starting the Slick algorithm, I gave it as a parameter. I want the 100 superpixel, or I want the 200 superpixel, and it's average this superpixel on the graph, and it's not big. It's not bigger. For example, this segmentation is not bigger than this segmentation. Yeah, there is no huge difference between all these two segmentation. There are every time they are taking average area of this, dividing n by chi, and this is the showing. This is the representing of the CLab color space. CLab color space 5D dimension. This is it's used RGB color as a color space, and also is coordinate of the every pixel. It's put coordinate of the every pixel, and this is the center of the superpixel in here. And every time when we are updating my center of superpixel, I'm taking the Euclidean distance between these two and average all of them. This is the logic behind of the Slick algorithm. After I create my superpixel using Slick algorithm, this is my tissue patch. For example, one of my classes, I think Benning class, and I apply superpixel segmentation in here, and it shows something like that. It's generally part divide as a nice group, and then I create my graph using region adjacency graph. Region adjacency graph is the easiest way to construct a graph. One of the easiest way to construct graph is just take every segment as a node, and every other neighbor as a neighbor in here. There's an edge all the neighbor of these nodes, and this is the region adjacency graph. I create for all patches one graph, and in my implementation I used two different types of experiments. This is one of them is I create 75 super pixel for every pages. This is for example, my 75 nodes. And the other one is I create 150 nodes for every pages. And I create graph from these two. And I have two data sets. Graph data set. One of them is nodes, 75 nodes. The other one is 150 nodes. And also in here, I want to show, for example, I show in here, I have one node in here, and I'm taking as a node of one graph. And in here, I'm taking, I'm doing feature extraction method on this segmentation. And when I'm describing node, I'm using these features on it. As a feature extraction graph, I used normal feature extraction, but and then I changed. I use one of the CNN method feature. I use VGG 19 from Keras, and this is the architecture of VGG 19, and it's the pre-trained weight ImageNet dataset I use. Pre-trained based on ImageNet dataset. ImageNet is the image dataset is very huge, and for feature extraction is generally used. And I tried this one. After creating my graph dataset, I use GCN, Graph Convolution Network, for graph classification. And in here is the general form of this. For example, I have many graph like that, and in graph convolution network, I'm creating the adjacency matrix of this one, and I apply the graph convolution network on it, and it gives me my label like that. As a result, I used Pamuk dataset. Pamuk dataset is very huge dataset, and hard to implement it. It takes a days to create construct the graph. And I used 10,000 patches for this experiment, and for each for the comparable part, I create 75 nodes graph and 100 graphs, and this is my accuracy. It's not seems it seems 54 and 56, and when I compare this the other work on this area, it seems like that, and I dismissed it. This is an article I on graph convolution network on images. There are two dataset in here. One of them is MNIST dataset. MNIST is a digit recognition dataset. Another is CIFAR-10 dataset. Is the object detection dataset. And in this work, they apply graph convolution neural network models on this data as a superpixel, like mine, S6 superpixel with these nodes. And according to their work, it shows that, I think they are not showing, but graph convolution network give test accuracy 90 on MNIST dataset, but it gives 54 accuracy on CIFAR dataset. I think about the structure of dataset, because MNIST dataset is more representable as a graph. I think that's why its accuracy is very well. And according to this benchmarking, this is my future work recommendation, and I'm trying to do also, I will try to do, trying the different feature extraction models. For example, using in pre-trained ImageNet CNN, I can train with my own data set. It can be triable. And the other one can be, maybe we can use different types of GNN models. For example, in here I use graph convolution network, but according to that benchmarking, maybe I can try getting graph convolutional network and graph attention networks. And thank you for listening to me. I can take a question.
Okay, thank you. Any questions? Okay, thank you for your interesting work. Okay, thank you. That concludes the end of session. Thank you.
Thank you very much. After the coffee break, we will continue next part.
Não havia mais olha, eu. Não, mas não se vai separar. Depois no meio da apresentação, aquilo vai ficar um bocado mais. Mas mesmo assim, eu garanto que raio, a pontuação que eu estou a tirar são um grande mas isto é uma questão para a certeza. Não, o que interessa trabalhar. Aliás, ninguém está a ler aquilo quando é concluído. Vai falhar o tempo. Sim.